So recall that Miss Gallus claims that she's an 80% free throw shooter. Miss Wilcox is skeptical and believes that she is less than an 80% free throw shooter. Miss Gallus has decided to take on another simple random sample of 50 free throws to prove herself. Okay, so write an appropriate hypothesis for the significance test. Be sure to define the parameter of interest. So first of all, we want to know whether or not she's an 80% free throw shooter. Okay? And somebody said, oh no, you're less than an 80% free throw shooter, which means that Miss G is exaggerating. Okay? Or Miss G is truthful. Okay? And P is the true proportion of free throws made by Miss G. Okay? Then it says describe a type 2 error in this setting. A type 2 error for this one would be something like Miss G is less than 80% free throw shooter, but we fail to reject the null. Okay? Suppose that Miss Gallus's true free throw percentage is actually 66%. Okay? And this is specifically talking about power of a test. Okay? So, enter all the information into the Statlet. Click to display type 2 error, and it'll show a blue shaded region. Okay, so. Alright, so if you click on that little applet, what you'll actually do is you'll set this to 0.8. 0.8, okay, because that's your null, right? And then we want to have less than 0.8%, right? Oh, less than, right? Okay. Then you want type 2, okay? And then the true value that we found was 0.66. Right? The sample size was 50 and your type 1 error is 0.05, right? Okay, so when you do that, you're going to get this. Notice how it has 0.24 right here for that type 2 error percentage. Okay, so going back to our Word document, we've got a 0.24, okay? If HA is true, what would be the probability of a good decision here? 0.76, which you can also find from here, the power, which is 0.76. Okay, so this is type 2 plus the power, which is going to equal 1. Okay, so again, this is type 2, and then this is the power. Okay. Also want to include that you've got for 66% for power, you must have a specific alternate value. Okay. Now it says, interpret the probability of this good decision in context of the problem. Okay, so determine that probability in context of the problem. So let's go ahead and scroll down just a little bit. Okay, so when we interpret it, it says that if Miss Gallus is a 66% free throw shooter, there is a 0.76 probability that we decide correctly that she was exaggerating, which we're going to reject the HO. Okay, So this is the probability of rejecting the HO given that HA is true. Okay, this throws back to like geometry days, right? Okay, so then it says click display power. We want to increase the power of our test. How could we adjust each of the following factors to increase our power? So going back over to this, it says you want to click display power. Click display power. Oh, there it is. Sorry. Okay, so if you click this little button that says power, we want to increase the power of our test. Okay, so if we increase the sample size, let's look at what happens. Okay, so we increase the sample size. What happens? Increasing sample size decreases variability, which decreases the overlap. Come back over here. Increase sample size, decrease variability, which decreases overlap. Okay, let's go back. Now let's look at the alpha level. So if we increase the alpha level, really didn't do much. So let's go back to sample size of 50 so we can see a little bit more. Okay, so you got to look at these numbers that are up here at the top. So if we go from 0 to 0.05, if we increase it a little bit more, power is going up, type 2 error is going down. Okay, so coming back, if we increase our alpha level, so we increase the alpha, okay, it makes rejecting HO easier. Okay, and then the alternative P, so if we decrease that, okay, then what's happening? If we decrease P, we increase distance from null. And that was the other little like swoop that we had going on. So, moral of the story, to increase power, we either can increase sample size, increase alpha, or increase distance from null. Okay? Alright, so let's go over your big takeaways for today. So, Alright, so the big takeaways from this is basically type 1, type 2, and power. So on type 1, if your HO is true, you're going to reject your HO for type 1. For type 2, you got HA is true. You're going to fail to reject the HO. And then if your HA is true, you're going to reject the HO for power. Now, you're never going to have something that has an HO is true and then fail to reject the HO. Okay, so just keep that in mind. Okay, for power, you got reject your HO and your HA is true. So if HA is true at a specific value and context, there is a power probability of finding convincing evidence to reject the null. And the last thing is to increase power, you're going to increase sample size, increase alpha, and then increase the distance to the H. Okay? I would pause and go ahead and try to do your check your understanding, and then check your work. So on this check your understanding, a statistics major and a finance major decide to get married. In order to investigate their per person expenses, they select a random sample of guests they invite into a wedding and records whether or not each person plans to attend the wedding. They decide to test. Your HO is P equals 0.75, and then your HA is P does not equal 0.75. The power of the test to reject HO 0.75 when P is 0.7 using an alpha of 0.05 and N equals 25 subjects is 0.1. Interpret this value. This means if the true proportion of guests that will attend the wedding is 0.7, there is a 0.1 probability that they find convincing evidence to reject the null that proportion of guests in 0.75. Okay. Find the probability of a type 1 error and the probability of a type 2 error for the test in part A. So probability of type 1 error is the alpha level is 0.05. The probability of type 2 error is 1 minus power, which is 1 minus that 0.1, which is going to give you 0.9. All right. On part C, it says determine whether each of the values changing would increase or decrease the power of the test. Explain your results. So use alpha equals 0.01 instead of alpha equals 0.05, so that means that our alpha is decreasing. So power would decrease because the alpha level decreased, which makes it harder to reject null. Okay. And then we've also got this one that says your N equals 100 instead of N equals 25. So we're increasing the sample size. So power would increase because sample size increased. Okay. Again, you can go back and watch the video again if you need to, or if you have any questions, just let your teacher know. Okay.